Today on 21st Century Business, explore state-of-the-art technology, innovative business strategies, insights from cutting-edge corporations around the globe, a visionary look into the answers of tomorrow, today. Business leaders, business solutions, 21st Century Business.
Welcome to 21st Century Business. I'm Jackie Bales. When an industrial sensing technology emerges that doesn't require the use of nuclear components or X-rays, that's news. When it's more accurate than the other alternatives and green, that's news indeed. Joining us to discuss a new terahertz-based light wave technology is Richard Kurtz, President and CEO of Advanced Photonix Incorporated, or API. Welcome, Richard.
Thank you, Jackie. It's a pleasure being here.
First of all, Rick, what sensing applications are we talking about, and what limitations are seen with the older type sensing technologies?
Well, first of all, we're talking about doing quality control, process control, or non-destructive testing or evaluation, measuring physical properties on products that are being made. The other technologies out there, like you mentioned, nuclear gauges and X-rays, are very harmful to human beings, obviously. And so as a result, that's where terahertz has its advantage. And it can be much more precise or accurate in its measurement.
So tell us who API is and what you've developed that's so different now.
Advanced Photonix, or API, is a publicly held company listed on the New York Stock Exchange. And API is our symbol, so that's the reason we call ourselves API so much. We've developed a terahertz technology that is able to see through what we refer to as optically opaque materials, okay, and do subsurface measurements of physical properties, thicknesses, densities, moisture content, and alike.
And down to what level?
Down to the micron level. So when you think about a micron, you're talking about the thickness of a human hair, basically.
Amazing. Well, let's see the T-gauge in action in this 21st Century Business Field Report.
Advanced Photonix's terahertz technology, known as T-gauge, offers the industry a completely safe and highly accurate sensing technology. It was just what Appleton needed to take their assembly line to the next level.
We had a few reasons to select the new technology. One was to stay at kind of the forefront of manufacturing technology. Two was to utilize a non-contact measurement method. Our products tend to be very sensitive to handling, sensitive to contact gauges. The non-contact nature of the measurement was really something we were looking for. And finally, the ability to make multiple simultaneous measurements was really attractive.
By creating and leveraging a strong value-added reseller channel, Advanced Photonix has provided their end users a strong support system, from installation to integration.
The technology was easy to get familiar with once you understood what the core measurement technology is. It's really just measuring time. The support so far has been beyond our expectation. All of our issues that we've had have been addressed in a very timely manner. The other aspect that's been very positive is the remote access. API can access our system remotely and troubleshoot and even correct issues remotely without having to box up the system or box up components and send them back to the manufacturer.
With their emerging terahertz-based technology just now making its way into industry, Advanced Photonix and their T-gauge system is positioned to revolutionize the last frontier of sensing technology.
Rick, how long have you been producing terahertz systems, and in what industries have they been used so far?
We're on our 5th generation system today. The first systems were bought by NASA and used to measure the sprayed-on foam insulation after the Columbia disaster. They were looking for areas of delamination or weakness between the multiple layers they were applying. As a result, that was our first start with terahertz. Since then, the next one has been with the F-35 program with Lockheed and Northrop, where we're helping them on their quality control, building the stealth fighter. We're measuring the thicknesses, and we're actually measuring the fit and gap between all the panels on the plane itself. As a result, it's helping them build a better plane.
Now, your first commercial customer, did you say that was NASA?
The first commercial customer was NASA, and it was on the return to flight program. They knew they had a problem with the spray-down foam installation, and the multiple layers could have air pockets in there or areas of weakness, which we can see through up to 24 inches in thickness. So as a result, what they had to do is they had to re-inspect that fuel tank, and that was actually Lockheed also re-inspecting it as part of that program. So we gave them 6 systems, actually sold them 6 systems, that they were able to validate that they had the proper adhesion between all the layers and reduce the amount of spray-down foam insulation coming off before the Columbia disaster by 90%.
And what did it take to prepare this technology for industrial deployment?
Well, obviously when you're selling one-offs to the government, they're very, very expensive. The systems that we sold to NASA were about $750,000 each.
Wow.
But the cost of a human life is much higher than that, obviously. So we knew we needed to reinvent the semiconductor. We had to find lower cost components. We had to customize our own laser. We had to do all these internal things to lower the cost point so that it would be more acceptable for industrial applications, because they're basing their decisions on an ROI or return on investment calculation as opposed to trying to save human lives necessarily. So as a result, we were able, in our 5th generation system, able to reduce that cost from that 750 down below 200,000 today. Now, we can reduce it even further as the volume starts picking up because it's scalable. Right now, we're only scheduled to be building, 10 to 20 units a year. As that gets up to the 50 to 100, that price point can come even lower.
Amazing. Are any other companies out there producing terahertz sensor systems that can go online?
Not to our knowledge. There's laboratory models that are out there. And again, we've gone the extra mile and we're going after our UL and CE certification. These are certifications that really gives the insurance to the industrial customer that these are safe.
So overall, big picture, why is a terahertz system a superior sensing system?
Typically, the competing technologies like X-ray and nuclear gauges have to be used either in tandem or have to have multiple sensors used to take the multiple measurements. Whereas with terahertz, we can take all those measurements at one point in one time, online in real time.
Wow. Now, speaking of being safe for human interaction, I understand that one use for this terahertz technology could be for Homeland Security, for passenger screenings.
We were approached by In-Q-Tel, which is a quasi-government agency that takes funding from the 3-layer agencies like TSA, and they develop and they invest into new technologies. They were interested in us working with them to develop an anomaly detector that could be used for religious headgear inspection, because it's very difficult to inspect religious headgear in the walkthrough because you really don't get scanned around your head for safety reasons. So currently what they have to do is a self-pat down. So the person has to pat their religious headgear and they put a trace sample on their hands and they put it in a little sensor to see if there's any explosive. But it doesn't find potentially other things that would be dangerous. So as a result, they wanted us to use our technology not to subsurface image, which it can do, but to look for anomalies or things that shouldn't be located in religious headgear. As a result, we've delivered 3 systems to the TSA, and they're running through their evaluation phase.
Very interesting. Fantastic. What future uses do you predict for your terahertz technology? And what are your hopes for the company, Advanced Photonix?
Right now, we're in the process of adding value-added resellers. A value-added reseller is the person that's going to take our technology and actually integrate it into a manufacturing line. We know the technology, we know what some of the things it can do, but we don't know all the applications. So as a result, we're looking for people that can come in, take that, know a vertical market niche, and then apply it to those problems out there, because we don't know all the problems it can actually solve. So Thermo Fisher Scientific is one of our VARs. ACT, or Automation Control Technologies, is another VAR. We're looking at people that can monitor robots to do automated inspection. We're looking at new rep international reps. Shimatsu just signed with us, Shimatsu Precision Instruments it's called, and they have an exclusive for the Japanese military market.
Wow. It seems like such a major step forward in sensing technology, Rick. To do this without the nuclear hazard alone is remarkable in itself. So thanks for telling us about this.
Pleasure being here. Thank you.
And thank you for watching. For 21st Century Business, I'm Jackie Bales.